Okay, so this simple harmonic motion question, it is missing the actual end bit of it. That should say, determine the equation of displacement. Now, if you hear something in the background, that's just my two naughty pups playing. Okay, so first thing we're going to do is we're going to talk about these formulas down here. Now, simple harmonic motion works differently to just acceleration, displacement, velocity, because we're talking about simple harmonic motion, we're talking about something that's moving periodically like that. So like a spring oscillating or something that's going up and down, like maybe a clock face. Okay, so first thing we're going to do is we're going to use this fact we've got here about the acceleration, which relates to this one down here about the acceleration. So if we know that the second derivative of it is equal to minus w squared x, and we've got that that is minus 4x, then we can really say that w squared is equal to 4, because they are occupying the same position. So now w is equal to, take the square root of it, and you'll get plus minus 2. Now, I always write plus minus, dogs, because that's normally something, stop it, hey. Yes, sorry, because that's, you need to always have the plus minus, although we're probably going to omit the minus. Now, if you did choose to have it as a minus, it's fine, it's just later on, it'll end up cancelling itself out with the phase shift. Okay, so I've used that fact to start off with. Next fact that I'm going to do is this one here. I'm just going to show what we actually found there. So now I know that x is equal to a sine wt plus delta. So in this case, x is equal to a sine 2t plus delta. Now, it doesn't matter whether you choose to do sine or cos, your phase shift again will auto-correct that for you. Okay, so the next thing we're going to use is this fact here. So, v squared equals w squared, a squared minus x squared, close your brackets. Now, we've got our velocity that's given to us over there as negative 2. So, negative 2 squared is equal to 2 squared. Doesn't matter if that's positive or negative, you're going to get 4 either way. A squared minus 0 squared. So, if I had something in this bracket here, I'd still have to take this over to the other side first. In this case, I don't, but just don't forget your rules, If I had 4a squared minus 3, then I would take this over, and then I'd be left with this bracket, so then I could take the 3 over. So just be cautious of your rules. So a squared is then equal to 1 plus minus. No, it's not plus minus. No, it is plus minus. If I take the 4 over, I divide by 4, which gives me 1, and then I square root it, which gives me a positive and a negative solution. Hey, don't eat that. That's my paper. Okay, sorry. So now I can see that x is equal to, a is 1, so it's just going to be sine 2t plus delta. So now we're going to figure out what delta is. So I can see that I've got an x and I've got a t, so I'm going to substitute those in and I'll be left with my unknown there. So 0 is equal to sine 2 times 0 plus delta. Okay, so this bracket here, I'm going to be left with 0 is equal to sine delta. Now I can take the sine across. Sine inverse 1 of 0 is equal to delta. So if I draw my unit circle here, the values where sine will give me 0 are here and here, meaning it's at 0 degrees and 0 radians and pi radians. So delta in this case can be 0 or pi. Now that means that our equation can look like this. So it could be x is equal to, Polly, stop eating that, sine 2t, close bracket, because delta would be 0 in that case, or it could be x is equal to sine 2t plus pi. Now, if I think about these two equations, they are different. If I go to Desmos here, you can see that they're shifted by their phase shift. So currently, I don't have enough information to say which one is which, because getting an answer of negative pi on 4 is very different to getting an answer of, negative 1 is very different to getting an answer of 1. Okay, so we're going to have to check. Now, we've used the formulas that we can. So the next thing that we're going to check is we're going to use the first derivative. So if I calculate the first derivative, which is the velocity of this function, then sine will go to cos. If I think about it in the form of the delta bit here, then deriving this is going to just leave me with 2. So 2 will come to the front, and then the bracket doesn't change. Okay, so if it's in this form, I can just test the statements. If I let delta equal 0, then velocity is still equal to negative 2, which is equal to 2 cos 2 times 0, because time is 0 and velocity is equal to negative 2, plus 0. Cos of 0 is going to, if I draw my unit circle, at 0 degrees, cos is at 1. So that's going to be negative 2 is equal to 2 times 1, which is going to be 2. Now, that statement's not true. So it must be the other one. Let's check. So if I change this to pi, I'm just doing this because I'm running out of space. Now, cos of pi degrees is over here at negative 1. So then I would have negative 2 is equal to negative 2. That statement is true. So therefore, we can say that the displacement function is truly equal to x equals sine 2t plus pi. And that will fit all of the other information that we've got. So we've successfully determined the equation of displacement. All right, next question that I think you should try today. Either you continue working through the IA3 revision important questions document. It's got worked solutions to go along beside it. If you find something that you think is incorrect, send me an email or ask the people around you to double check. Otherwise, this question here is from IA3. It was a sample provided, so if you go to the video links document, it is this one here. So click the link if you want the video. Answers are over there. Otherwise, good luck for today.